So he's saying, essentially what he's saying, y cannot be equals to any odd multiple of pi, right now?
Yes, sir.
Yes, sir.
Okay. Because whenever y is an odd multiple of y, what will happen to the denominator? It will become 0. Cos y will become minus 1, no?
Yes, sir.
Okay. Okay.
Yeah, understood, sir. We just applied chain rule basically.
We just applied implicit differentiation, this one. Okay.
Got it,
Good.
got it.
Okay. So this one, how will you do? Tell me. Sine inverse x. How do you differentiate?
Sir, it's 1 by root of 1 minus x square.
Right, right. But how did you get that?
Sir, it's a formula.
It is a formula, but you should know how to derive that also. Okay. So what you are doing, sine inverse x is actually something, right?
Yes, sir.
Yeah.
Okay. Sine inverse x is actually, we assume sine inverse x equals to some y. Okay, ma?
Okay, sir.
Okay. What does that mean? Sine y should be equals to x, no?
Yeah.
Okay. Now do implicit differentiation. If you do left side and right side differentiation, what will happen? Dx by dx is left side. Should be equal to cos y dy
1.
by dx, right?
Yeah.
So dy by dx become what? 1 by cos y, right?
Yes.
1 by cos y is what?
1 by cos into
Cos y.
sin inverse x.
Okay, so cos y is nothing but square root of 1 minus sine square y, right?
Yes.
Okay, but what is sine y? Sine y is nothing but x, right?
Yeah.
So which is nothing but 1 minus x square, right? So 1 by
Okay.
cos y is nothing but 1 by under root of 1 minus x square. Okay, ma?
Okay, sir.
This is how we get this. Okay. Similarly, do the differentiation of tan inverse x. Shreyas got it, no?
Yes, sir.
I got it, sir.
Differentiate tan inverse x.
Sir, I got the answer.
How much?
Sir, I got 1 by 1 plus x square.
Very good, excellent. Cot inverse.
Oh, I should do it now.
Cot inverse. Cot inverse. Very good. This is correct. Do it for cot inverse.
Sir, won't it be 1 plus x square itself?
Cot inverse x. No, you will
Like the
get a negative
reciprocal.
sign. You will get a negative sign.
Oh,
Just
yeah.
check.
Is it like
Minus of.
minus 1 by 1 plus x square?
Very good. Minus 1 by 1 plus x square. Right now.
Oh, yeah. Yes, sir.
And what is cos inverse?
So it's the negative of sine inverse.
Negative of sin inverse. Very good. Shreyas, you got no more?
I
Okay.
also got it, sir.
Okay. This is how we differentiate inverse trigonometric functions. Okay. See, tan inverse. We got 1 by 1 plus x square, right? So
Yeah.
similarly, you can do for all of this. Okay. Now, now, secant inverse, can you try once?
Yes, sir. Sir, is it 1 by x into 1 minus x square?
1 by x into
1
1
minus
minus
x
x square
square.
or x square minus 1?
Oh yeah, yes sir. It is. It will be like that.
It will be 1 by x into square root of x square minus 1, no?
Oh yeah, yeah. Square root is also there.
Square root of x square minus 1, right?
Yeah,
Okay, now you notice one thing. Here there is a mod x, right? It's not directly x,
yeah.
right? Why is it putting a mod here? Okay, so uh, we know the graphs of sin x cos x. We discussed those graphs, no?
Yes,
We discussed those graphs in the beginning, no? Somewhere I think we discussed, right? We discussed the graphs of sin x cos x, all these things, no?
yes sir.
Okay, so you remember how to plot all the graphs and inverse graphs?
Yes sir.
Okay, so I'll show you some other picture. Okay, some other tab ones. Okay, you remember this slide, ma?
Yeah.
Earlier we discussed, right? We discussed about all
Yes, sir.
we discussed what is sin x. Sin inverse x is actually reflection with respect to the line y equals to x, no? You remember this?
Yeah.
Sin inverse x. Cos x is actually reflection again with respect to this line, right? So that's why this went to the other way, this way, right now?
Yes.
Okay, these are all reflections, right? Now, secant x is this and secant inverse x is this, right? This one reflection with respect to that line y equals to x is this. Okay, ma? Okay. Now, if you closely observe this one, the slope of this graph, right? The slope of this graph is always positive. Can you see? Here, if you draw a tangent, it will go like this, it will go like this, it will go like this, right? The slope of this graph is always positive. Do you agree?
Yes.
Yes,
Do,
sir.
do you agree? So, for example, the graph left side, it will look like something like this, right? Okay. What is the slope? At any point, if you take, the slope is like this, or the slope is like this. The slope is like this, right now?
Yes.
Okay. The slope is always like this, okay, or like this. Right now, the slope is always positive, right? Because slope negative means the line should look something like this, right? Backward line, right, Noma?
Hmm.
Okay. So here also the slopes are always positive. Here also the slopes are always positive. Okay. For example, cosecant x, the slopes are always negative. Do you agree?
Yeah.
Agreed. This one, the slopes are always negative, like this. Here also, everywhere negative. Here also the slopes are always negative, cot inverse, right? Here the slopes are always positive. Here slopes are always negative. Here slopes are always negative. Right now? Okay. Similarly, sine inverse, the slopes are always positive, right? Cos
Hmm.
inverse, slopes are always negative. Tan inverse, slopes are always positive. Agree?
Yes.
Okay. Now let's go back to our this thing. Okay. Now, because the slopes are always positive for sine inverse, right? Obviously, what is f dash? F dash means slope of the curve, right? At some point, right, Nama?
Yes sir.
Okay, and we realize cos inverse, the slope is always negative. That's why you should get -1, which you got -1 only, right? Cot inverse also you are getting -1 by default without doing any additional manipulation, right? But whereas here you got x, right? You did not get a mod. But if you keep x, when x is negative, this entire value will become negative, right? You understood what I'm trying to say?
Yes sir.
Yes,
Okay.
sir.
The slope, we are getting this kind of curve, right? Where the slope is always positive. That's why we're keeping a mod. Otherwise, when x is less than 0, right, this becomes negative, right? Right. And cosecant inverse x, we observe that slope is always negative. That's why again we are putting a mod and put a minus here. This minus we are anyway getting. Here we are putting this mod. Okay. To force it to always be negative slope. Okay, ma? That's the reason why mod is there. Okay. Agree?
Agreed, sir.
Okay. So now you can do differentiation of this, right? We can assume sine y equals to this thing, right? You can do this way also. Sine y equals to this thing, and you can differentiate this. Okay. So these problems fine. Then 5.2 5.2 you have done, no? If you haven't done, please do it once. Okay.
Yes, sir. 5.2
5,
is done.
5.2 is
Sir, I
done.
cannot. Okay, you're not screen sharing anything, right?
Am I not?
No, sir.
Oh,
I can't
sorry.
see anything.
Sorry. I was writing also. Okay. Can you see my screen, mark?
Yes, sir.
Yes, sir.
Okay. So 5.2 is done, right? This one, tell me. Do you know how to do logarithmic differentiation? This one.
Yes, sir.
This one you can do, no?
Oh, yes, sir. That's fine.
These,
Logarithmic
these, these all things
differentiation
you
we
can
know
do.
to.
Okay. So these all things you can do. One second, man. These all things you can do, no?
Yes, sir.
Yes, sir.
One second. Can you hear me, ma? Sorry, I got a call. Huh. Hello.
Yes, sir.
Okay, very good. So now logarithmic differentiation. You know how to do logarithmic differentiation?
Yes,
This,
sir.
this one you
Yes,
know, no?
sir.
These things you can do, right? X power x, how will you differentiate? X power sin x.
Sir, what? Can you
X
repeat
power
the
sin
question?
x. This one. How will you differentiate this one?
Sir, it's sin x log x. Yeah? Log y is equal to sin x
Very good,
log.
very good. You know how to differentiate this, no?
Yes, sir.
This kind of function you know how to differentiate, no?
Sir, are you like,
You
sir, are
can't see
you,
my screen?
sir, are you displaying 5.4? Exercise 5.4.
Yes,
Okay.
sir.
I think the screen is not scrolling, I think. I am displaying.
Sorry, yeah, it shows example 5.4.
Screen is not
Exercise.
scrolling. Okay. I think I should rejoin. I don't know what is happening. Let me rejoin.
Yes, sir. Now example 33 is seen.
Right. This one can you do?
Yes, sir.
Hmm. Tell me exercise 5.5. Can you do all of this?
Yes, sir. This is fine, sir. This is what sir said. Now, in the first question, we used the one of the formulas. Yeah.
Okay. But
After
you
taking
can
log
you
y
can do no?
equal to log.
You can do all those questions. No? All 18 questions
Yes,
you
yes.
can do. No.
Yes, sir.
Okay. Very good. And what about parametric form? You can do this kind.
So this one we have to like revise once. So it's like you take the third variable or something and then
No. This is very easy.
derivate both of them.
Right.
Suppose
Exactly.
dy
Exactly.
by dx, use dy by d theta
Dy
divided
by
by
d
dx.
theta and dx by d theta, and you take ratio of both. Okay.
Yeah.
This you can do now.
Yes, sir.
Here, what is the third variable? You do dy by dt, dx by dt, and take the ratio of both. Okay.
Okay, sir.
Here, dy by d theta, dx by d theta, and take the ratio of both. Okay.
Okay, sir.
This one, he has taken some substitution. Okay. He has taken some substitution. Okay. Or otherwise, also you can directly do.
Yes, sir.
Okay. Without substitution, also you can do. So these all things you can do now. Dx by dt, dy
Yes,
by
yes.
dt. Okay.
So this is 6.6.
This is 5.6.
Oh, yeah, 5.6.
You can do
Yeah,
no?
yes, sir, this is fine.
This is fine. Okay. Second order derivative. This part is there for you in your book or not there?
Sir, it is there.
It is there, no? Okay. Two derivatives can you do? This one, example 38.
Yes, sir.
This you have to differentiate twice. Okay. This one 39 you can do, no?
Yes, sir.
Yes, sir.
Okay. Very, very good. So all these questions you can do. Just look at this 5.7.
Yes, sir.
You can do, no?
Oh, yes, sir.
Okay. All of these questions you can do, no?
Yeah.
واحد معاه هنا شباب دخل السايت
Okay. You can do all of this, no more?
Yes, sir.
He's asking you to verify. You can do all of this. Okay. Mean value theorem. Did we discuss mean value theorem? It is there in our book or not?
Sir, no, sir.
It is not
It's
there,
not
but
there. 5.6 is the last one, like the second order derivative one.
Yeah,
second
that's
order.
it, sir.
This is there. Okay. But
So
mean
it's,
value theorem is actually very important for this thing also.
في واحد
Uh,
يسمعك اذا كنت صار مشغل المايك
okay. But anyway, let us discuss this. Okay. One is mean values and what else is there? Okay, mean value theorem is there. That's it. These parts, these questions are not there in your book. This part is not there,
Mm,
no? This you can do, no? F of x sin x power sin x. This is a logarithmic differentiation, right?
Yes, sir.
Okay, cool. So then miscellaneous questions. Okay, these are miscellaneous questions. Okay, mean value theorem. I will explain. Okay. So see here we are taking some function. Okay, some function from a b, right? And a and b are closed brackets. Okay, and this is continuous on closed brackets ab. Okay, and differentiable on open brackets. Please notice the brackets. Okay, here these are closed and here these are open. Okay, and f of a equals to f of b. Okay, ma. Then what
Okay,
is
sir.
saying between a and b numbers, then there exists a comma b such that f dash c equals to 0. Okay, so what he is essentially saying is there is a function. Okay, f of a is equals to f of b. So there is a function f of a is some point, f of b is the same point. Okay,
okay, sir.
this is a, this is b. Okay, at f of a, f of b, both are of same values, right? Now,
Okay.
the function is differentiable on AB. Okay, this is open brackets AB. What does that mean? At everywhere in between, the function is actually smooth, right? There are no these kind of things. There are no these kind of things, right? The
Yes,
function
sir.
is differentiable on AB and the function is continuous on AB. Here, these are closed brackets, okay? So that means these kind of breaks are not permissible. These kind of spikes or corners are not permissible, right? Okay. So basically, if a function is a smooth function, this kind of function, where f of a equals to f of b, then what is saying, if this is the case, then there exists some c between a and b. Okay, there is between a and b there is some c where f dash c equals to 0, right? This is equals to 0, right? Now, right? Understood. So what he is trying to say is, if you are started at a point and if you are reaching the same point, then you would go through some way and at some point it have to, if you are going up you have to come down, right? That means the slope will become 0. Agree? F dash c equals to 0. What does that mean? The slope is equal to 0 now. Agree, ma?
Hmm.
Agreed, sir.
Okay, Pratik, do you agree?
Agreed, sir.
Okay, at some point between a and b the slope has to become 0. What does that essentially means is, if you are starting at some point and reaching the same point, if you are going down eventually you have to go up, right? At least, okay, if you are going up eventually you have to come down, right?
Yes.
So there will always be one point in between, minimum one point, where the slope should become 0, right? There could be more points like this. It will go up and down multiple times, right? Then there are more points, right? More
Yes, sir.
places where it
Yeah.
becomes 0. But it guarantees if you are starting at this point, you are reaching the same point. At the same time, you are always continuous and always differentiable. That means there would be minimum of one point where the slope will be 0. Agree now? Very basic common sense only this is, right now?
Yes, sir.
Okay. Now, the interesting thing, the important thing that we have to notice here is there is this open bracket AB and there is this closed bracket AB. Okay. Why is he talking about differentiability on closed AB but continuous on open AB? Okay. Okay. Sorry, continuous on closed AB, right? Why it is needed that this one is continuous on closed AB. Okay.
Okay, sir.
Okay. This one has to be continuous on AB and differentiable on open AB. So, for example, if it is not continuous on AB and f of a is not equal to b, you can always start a function from here and go somewhere here, but your slope will not be equal to 0, right? So, firstly, f of a and f of b have to be defined, and that's why continuous on AB. Okay, or otherwise, you can always create a function like this, right? Okay, so it is not continuous, it is breaking, right? It is not continuous. The function might be defined at all places. Okay. At this point, the slope need not be equal to 0, right? Okay. You can always create a function like this. Agree, ma?
Yes.
Agree?
Yes, sir.
Okay. So when it
Thank you
is
so much,
not
sir.
continuous on AB, if there is a break, then you can always
Take your
do.
turn. So,
Basically, in fact you can create a function like this also, right? The slope is positive, the slope is positive because there is a break. Okay. Or the slope is positive and the slope is negative, right? Okay, but the slope is never zero. You are reaching the same point where you started, right?
Yeah.
Okay. Or you went there,
5 minutes.
you came down, you are reaching the same point, but your slope will never zero. So that's the importance of continuity. Okay.
Okay, sir.
If it is not continuous, then you can always create a function where without slope being zero, you can reach the same point, right now?
Yes, sir.
Okay. Now, without differentiable, why this one is important? Because again, you can start at here, you can go like this, right? And you can come back like this. Here, the point is not differentiable. The slope is never zero. Understood?
Yes,
Yes.
sir.
You can go like this, you can come back like this. Okay, that's the importance of differentiable. It has to be differentiable. Because it is not differentiable, you are
Just
able to
one
create
question.
a function
Why you want
where
to
where
use the account?
between A and B, the slope is never zero. Okay, ma?
Yeah, fine, sir.
Okay. Now, please notice the differentiability is saying the differentiability need not be there at A and B. Okay, see, here it is close bracket. Here it is open bracket. Okay, so why?
Yes, yes, with,
Because this kind of function is permissible, right? Here the slope is infinity, right? At A and B, the slope is infinity. Okay, that means at A and B, the function is not differentiable. Agree, ma?
Agreed, sir.
At A and B, if you are putting this condition, that means you are putting an extra condition, right?
chill, guys, chill.
You are putting an extra condition where you are forcing it to be differentiable at A and B also. But here at A and B, it can be like this, right?
Yeah,
You
avoid.
can
والله ما
have
في أي رسالة
infinite
بلاش
slope,
تلعب for the one.
right? No, ma?
Yes, sir.
Okay, that's why at A and B it's actually open bracket. You don't actually need a closed bracket. It doesn't have to be differentiable at A and B at the point A and B. But once you cross A, it should be differentiable. Okay.
Okay, sir.
Okay, that's the reason behind the open bracket. Okay, understood now? So the
Okay, sir.
function should be defined at all A and
Yes,
B,
sir.
including A and B. Okay, and it has to be continuous at all A and B, including A and B. But differentiability need not be at A and B. Even if it is differentiable between A and B, open, that is still fine. Okay, ma?
Okay, sir.
Okay, if that is happening, then what is the Rolle's theorem ensuring? It is ensuring that there will always be some point in between where the slope is zero. Okay, agree.
Agreed, sir.
Okay, so an extension of Rolle's theorem is Lagrange's mean value theorem. Okay, so this is called mean value theorem. Okay, now look at this mean value theorem. Here it is saying again A to B to R. Okay, now differentiable on AB, same. Okay, same condition, closed and open. Okay, then what is saying there exists here f of A need not be equal to f of B, right? Here what is saying there exists some C in A comma B such that f dash equals to f of B minus f of A by B minus A. What exactly is saying? F of B minus f of A by B minus A. What does that mean? This is y2 minus y1 by x2 minus x1, right?
Yes.
Okay, so there is a function. There is a function from A to B. Okay, something like this. Okay, and this part is y2 f of B. This part is f of A. Okay, y2 is f of B, right? Y1 is f of A, right?
Okay.
X2 is B,
Okay.
X1 is A, right?
Yes.
Y2 minus Y1 by X2 minus X1. Okay, this is the slope. What he is saying, okay, if you connect these 2 points by a straight line, you will get some slope, right? This slope is what? If you connect these 2 points by a straight line, the slope of that line, right now?
Yeah, fine. Yes, sir.
Okay, this is A, this is B. What he is saying is there exists some point between A and B where this slope, the slope of the curve, that means if you draw a tangent, that tangent is actually parallel to this one. Okay,
Okay, sir.
understood. So that is the figure, right? If you connect these 2 points with a straight line, what do you get? F of B minus f of
Oh,
A
stop,
by
stop.
B
Oh, chill,
minus
chill.
A. Okay, that is the slope of this line. Okay, now what he's saying is there will always be some point between A and B at which the slope of this curve has to become has to be parallel to this one. This is nothing but a slant version of Rolle's theorem. Rolle's theorem, what it is saying? F of A
Okay.
equals to F of B. That's why that straight line
But
is parallel to
let
x-axis.
the smoke go.
And there will always be some point in between where this line is parallel to this x-axis, right? Whereas this one is saying, if you are starting here, if you are going there, you can go whichever way, but on an average, the slope will be something, and at some point, the slope should match. Okay, there could be more
Why
points. There could be more points, right now? Like in the previous case, if you are starting here, if you are reaching here, right, there could be more places where the average slope. Okay, what is the average slope? The average slope is this.
yeah.
Okay, average slope is actually matching slopes at particular instance. Okay, there could be more instance, but at least once it should match, right? If you are traveling from A to B, let's say your average speed is 50 kilometers per hour, then what does that mean? At least once your speed should be 50 kilometers per hour. You cannot be always be less than 50 or always be over 50, right? At one point you have to cross 50. Otherwise your average will not come 50, right? No?
Thank you.
Agree?
Yeah.
Agree. The same logic here. If on an average your slope is this, at least at one point the slope should be same as average, right? This
Yeah.
is Lagrange's mean value theorem, and that one was Rolle's theorem. Okay, ma?
Oh,
These 2 points you are clear now?
Yes, sir.
Okay. So then I think this is anyway not there in our syllabus. Okay. So
I don't have like
you don't have, but you know the Rolle's and mean value theorem. No, this you need in JEE. Okay. You skip this. Then this chapter is done in school, no? Then
No, sir.
no, sir. Sir, we are in the logarithmic differentiation, sir.
logarithmic differentiation only.
That I think we're in like the last few questions. That's it.
Oh, okay. Logarithmic differentiation,
Yeah.
right? Which one? Parameter is there. Parameter is still you have to do.
Yes, sir. We
Yes,
still
sir.
have to do parameter.
You
We
still
have
have
to
to
do
do.
so
Okay.
much.
Try to finish off that logarithmic and parameter also. Okay.
Okay. Yeah.
Okay. So those are easy only. Then so limits, continuity, and differentiability will be over with this, right? As per your textbook. Okay.
Yes.
So this one is there. Then there is something called application of derivatives. Okay. Application of derivatives. Let's see what your textbook is given. This is in school. It did not start this, no?
what's blank?
In school, this is not started, no more.
Sir, which one?
No, sir.
Application of derivatives.
No, sir. We didn't start.
Okay. So increasing functions, decreasing functions, tangents and normals. Okay, cool. Okay, let us discuss a bit about this. Okay. So application of derivative means where do we need derivatives? Okay.
Okay, sir.
Okay. In fact, that Rolle's theorem and Lagrange's mean value theorem is also kind of application. Okay. Is also kind of application only.
No, you go first, okay? You have alpha. No, you go first.
Okay. See, now look at this problem. Rate of change of area per second with respect to its radius when r equals to 5 centimeters. Okay. Okay, ma?
Okay, sir.
Okay. So what is he asking? dA by dr, right? Area of circle is pi r square, right?
Yes.
Okay. Now what
Yes,
is
sir.
saying when radius is pi? Okay. How is area changing, right? Okay. So what does that mean? dA you have to express in terms of dr. Okay. So rate of change. So what does this mean? Tell me. dA by dr. What does that mean? Rate of change of area with respect to change of radius. Right? No. dA by dr means what? change in
If you
area
go right,
with
someone
respect
if
to
you
change in
go
radius,
left.
right?
Yes, sir.
Okay, so these two rates are related. The point we are trying to say is dA will
نفس هذا قاعد نفس هذا
dA
وايد
equals to,
وايد.
we can write dA equals to 10 pi dr, right?
Yes, sir.
dA equals to 10 pi d. These two rates are related.
Dude,
That's the
there
whole
is
point
smoke.
here.
اسكت السجل اهدى.
Okay,
واحد
Nama?
فوق.
Okay, sir.
Okay. So here 9 cubic centimeters, what is saying? Volume is volume and length you have to relate. Okay?
باقي واحد هنا واحد رايت واحد on the right one on the
dV by
left.
dt,
قدر يا واحد
dV by dt and x you have to relate, right?
is back.
Okay, Nama?
Okay, sir.
Okay,
So did
so
you mute me?
yes, there is some noise coming from your side.
Oh, yes, sir. There's cleaning going on in the room. That's why I kept muting myself, sir.
Oh, okay. Which streaming is this?
Sir?
Which streaming?
Streaming?
What is happening?
Sir,
Some noise?
cleaning. They're doing vacuum cleaner and then all that stuff, sir.
Okay. Got it. Okay, cool. So, okay. See this thing. When f of x, there is some function f of x, okay? F of x is something like this, okay? Now, this function is increasing, let's say, okay? Function is increasing means what? The next point should be higher than the previous point, right now? The value of, let's say, if b is greater than a, what does that mean? F of b should be greater than f of a, right, Nama? A function is increasing, what does that mean? The next point should be higher than the previous point, agree or not?
Yes, sir.
Okay, so what does that mean? The slope should be positive, agree or not? If a function is increasing, the slope should be positive, agree?
Yes, sir.
If the slope is negative, means what? The next point is actually lower than the previous point. Slope positive means these kind of lines, right? Slope negative means these kind of lines, right?
Yes,
If
sir.
a function is increasing, what does that mean? F dash x should be greater than 0. As easy as that. Agree now?
Yes, sir.
If the function is decreasing, what does that mean? F dash x should be
F
less
dash
than
x should
0.
be less than 0.
It should be less than 0. Very simple. Agree now? So these all functions, they are increasing functions. That's why slope is positive. Here slope is negative. And the f dash x equals to 0. What does that mean? Slope is constant, right?
Yes, sir.
Okay. So f dash x equals to 0. What does that mean? Slope equals to 0, right? That means it's a constant function. Okay, ma? F dash x
Okay,
means
sir.
slope. Agree. Slope equals to 0 means what? It is neither increasing nor decreasing. Okay. Okay. So for example, this is a straight line. What is the straight line? 7x minus 3. Slope is 7 and this is a straight line, something like this. The slope is 7, right now mx plus c. Okay. And because slope
Yes, sir.
is, because f dash is greater than 0, what does that mean? Obviously, this is an increasing function. Okay.
Okay, sir.
Okay. Now, this is what he is saying. If it is increasing, f dash is greater than 0, decreasing f dash x less than 0. Okay. And constant function and f dash x equals to 0. This you agree, right? Now
Yes,
he
sir.
is saying this function, it is always increasing is what he is saying. How do we prove this? How do we prove this is we differentiate this function and we are getting someone, right? We got this. And then now he is saying that this is actually perfect square plus 1. Okay. So that means f dash x is always positive. That means this function is always increasing function. Okay. It will never decrease. That's what he is trying to say. Okay. Agree, ma?
Agreed, sir.
Okay. Here
Agreed,
function
sir.
f of x is decreasing in 0 to by increasing this thing, neither increasing nor decreasing. He is saying something. Okay. So now what is f dash x? F dash x is minus sin x. Okay. Now this
Okay, sir.
minus x sin x between 0 and pi, this is actually negative. What does that mean? Slope of this function is negative between 0 and pi. Right now? Have you
Yes,
understood
sir.
this? F dash x is what? minus sin x, right? Minus
Yes.
sin x is negative between 0 and pi, right?
Yes.
What does that mean? This function's slope is actually negative, right? This function slope is actually negative. So that's why this cos 0 and pi, this is the point, right? This is pi, right? So between here to here, cos x, the slope is actually negative. Obviously, the function is decreasing function. Okay?
Okay, sir.
Okay, between pi and 2 pi, again, sin x is actually negative and minus of sin x, that is positive, and that's why the function is again increasing. Okay? Understood?
Yes, sir.
Okay? And neither increasing nor decreasing between 0 to 2 pi, because sometimes it is decreasing, another time it is increasing. Okay? So, in this interval in which function is increasing or decreasing, what does that mean? You differentiate this, and whenever it is positive, 2x minus 4 is positive, that means it is increasing, right? And whenever it is negative, that means it is decreasing. Okay? When is 2x minus 4 positive? When x is greater than 2, right? When x is
Yes.
greater than 2, the function is increasing. Function is increasing. Okay? When x is less than 2, the function is decreasing. Okay?
Okay.
Understood, no? Similarly, this one you can do, right? This one you'll do differentiate this until and check when it is when it is positive, when it is negative. Okay, this kind of thing, do you know how to okay, tell me this one, when is it positive, when is it negative? X
Sir,
minus 3
when
into x
it's
plus 2. How will you tell x minus 3 into x minus 2, when is it positive, when is it negative?
sir greater than 3 and minus 2.
Greater than 3 and okay,
Minus 2 is positive.
no, I didn't understand. Greater than 3 and
Greater than minus 2.
no, but that essentially means greater than minus 2 only, no? This both together, that means x greater than minus 2 only, right?
Yeah.
So what does that mean? Do you mean to say x greater than minus 2?
Hmm. Sir, between minus 2 and 3.
Between minus 2 and 3, it is negative, no?
Yeah.
Okay, so the way how to do this is, okay, x minus 3 and x plus 2, okay? Forget about 12. 12 is anyway positive. Okay, this
Okay.
one is actually 0 at 3 and minus 2, right now? At all other places, this is positive or negative, okay, ma?
Okay, sir.
At x equals to 3, it is 0, and x equals to minus 2, then also it is 0. At all other places, it is actually positive. Okay.
Okay,
So,
sir.
now x minus 3 and x plus 2. Okay. When is x minus 3 positive? Whenever x is more than 3, right?
Okay.
Okay. All before 3, it is negative, right now? When is x
Yes,
plus
sir.
2 positive? When x is more than minus 2, right?
Yes.
Okay. Right. And before minus 2, it is negative, right? Now, now this is actually product of these two. So product of both negatives, this is positive here, negative here. Product of both positives, positive here. What does that mean? Essentially, when x is greater than 3 and when x is less than minus 2, this product is actually positive. Okay, Mark?
Okay, sir.
Okay, x is greater than 3 and x less than minus 2. Okay, then it is positive. Between minus 2 and 3, this is actually negative. Okay,
Sir, what can you explain again?
okay. So this is product of these two. Okay, Mark?
Okay, sir.
Product of these two, and now we are individually checking when is each one of these is positive. Okay, x
Okay.
x
Okay, sir.
x minus 3 is positive when x is greater than 3. Remaining all places it is negative, less than 3. Okay, left side of 3 I'm marking negative. Okay,
Okay, sir.
okay, and x plus 2 is positive when x is greater than minus 2. Okay, so right side of minus 2 I'm marking positive, left side of minus 2 I'm marking negative. Okay,
Okay.
now the product of these two, that means a negative number into negative number, that should become positive, right?
Yes.
And negative into positive, this will become negative, positive into positive will become positive, right? At all
Yes.
places. That means before minus 2, the product of two numbers, you will get a positive number, right?
Yes.
And between minus 2 and 3, you will get a negative and positive together negative, okay?
Okay.
After 3, you will get a positive number, right?
Okay. Okay.
Essentially, what does that mean? After 3, the product is positive. Before minus 2, the product is positive, okay? And
Okay, sir.
between minus 2 and 3, the product is negative, right now?
Yes, yes.
Okay, so or otherwise you can see this as x square minus x minus x. This is a quadratic equation, right?
Yes.
That means it's a parabola, right? Right now?
Yes, sir.
Quadratic equation. And what are the roots? One is 3 and one is -2, right? And
Yeah.
this parabola is always facing upwards because coefficient of x square is positive, right now?
Yes, sir.
Okay, so this parabola will look something like this. Okay, so beyond 3, it is always positive. Before -2, this is always positive. And in between -2 and 3, this is negative, right now?
Yes, sir.
That is what we are saying here. Okay, now the same method will apply even if you have multiple factors. Right? For example, x minus 3, x plus 4, x minus 7, whatever. Okay, then what will you do? You take each one of these individual factors, x minus 3, x minus 4, x plus 4 and x minus 7, and you mark all the places in ascending order where all this becomes negative, where all the places -4 and 3 and 7. Okay, mark.
Okay, sir.
Okay, then you keep marking positive. X minus 3, when is it positive? Plus here, and other places negative. X plus 4, plus here, plus here, plus here, negative here. Okay, x minus 7, plus here, negative here, negative here, negative here. Okay, mark.
Okay, sir.
Okay, and then you multiply all of this. This becomes negative, this becomes positive, this becomes negative, this becomes positive. So beyond 7 it is positive, and between -4 and 3 it is positive, and remaining places it is negative. Okay, ma?
Sir, can you explain how you decide the signs again?
Okay. So we have, this is multiplication of three numbers. Okay.
Okay, sir.
Okay, we are talking about multiplication of three numbers. Okay. Now individual numbers, when are they positive, when are they negative is what we are checking. Okay.
Okay.
X minus 3, when is it positive? When x is greater than 3, right?
Yes.
So that's why this is positive, greater than 3, this is positive, and we are looking at different buckets only. Okay, and
Okay,
as
sir.
long as x is towards the right of 3, that is this and this, it is positive. Towards the left of 3, it is negative. Okay,
Okay, sir.
x plus 4, when is it positive?
When it's greater than -4.
-4. So towards the right of -4, it is positive, 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 positive. Towards the left, it is negative. Okay,
Negative. Yeah.
okay, x minus 7,
Sir, x minus 7 when x is
right of
greater than
7,
-7. Yeah.
greater than 7, right? So this is
Yes.
positive here, negative, negative, negative. Okay.
Okay, sir.
Now you are multiplying these three numbers.
Sir, how
Okay.
do you get four signs though? Like there are three numbers here.
So the fourth is actually multiplication of these three, right? The net result is the multiplication of these three. No,
Yeah.
understood. The final result is what? This is multiplication of this, right?
Yeah.
So negative, negative, negative. So overall net result is negative. Okay.
Okay, sir.
Okay. Positive, positive, negative. Sorry, negative, negative, positive. Net result is positive. Okay, ma.
Okay, sir.
So likewise, negative again positive. Okay. The fourth one is actually the final result of multiplication of all of this. Okay.
Okay, sir.
Okay. The trick here is how many factors you have. What you will do, you will arrange them in terms of ascending order. Okay.
Okay, sir.
And keep it putting this plus minus sign. Okay. So
Okay,
at
understood.
some point, all of these are negatives, and it will start becoming positive at a point. So all of these are negatives, it will start becoming positive. All of these are negatives, it will start becoming positive. Okay. Each
Okay,
of
sir.
this factor will become positive at some point, right?
Yes, sir.
Okay, you mark all the positives and negatives and then finally evaluate. Very basic thing only. Okay,
Okay, sir.
understood? No?
Understood, sir.
Okay, so these kind of things, that way it will become very easy. Okay,
Okay, sir.
okay, cool. So, now, so he's saying the same thing, right? When is it negative, 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 positive, negative, whatever. Okay, see here, this kind of thing, sine 3x, when is it increasing, when is it decreasing? What do? You differentiate, you will get 3 cos 3x, right?
Yes, sir.
3 cos 3x, when is it positive, when is it negative? That means 3 anyway you can skip. Cos 3x, when is it positive? When 3x is between, what is saying? Uh, cos 3x is 0. Okay, okay, fine. Cos 3x, when is, okay, no, do this and tell me. When is this positive? Tell me. Between 0 to pi. X can lie between 0 to pi by 2. Okay? You understood the question number?
Sir, can you repeat?
Okay, so he's asking when is this function increasing? Okay,
Okay, sir.
when is this function increasing? When its derivative is positive, right?
Yes.
That means this one should be positive, right?
Yes, sir.
If this one is positive, 3 is anyway positive, what does that mean? Cos 3x should be positive, right?
Yes, sir.
Okay, cos 3x. When x is lying between 0 to pi by 2, okay, 3x, cos 3x, when is cos 3x positive? That is the question, right?
Yes, sir.
Okay, so now cos 3x, when does it change sign? So basically cos theta, when does it change sign? At pi by 2 it will change sign, right?
Yeah.
And at 3 pi by 2 it will change sign, right? Between
Yes,
pi
sir.
and pi by 2 and 3 pi by 2 it is negative. After 3 pi by 2 it is positive, right now?
Yes, sir.
Okay, so if 3x is belonging to 0 to 3 pi by 2, okay, so now look at this. When x is belonging to 0 to pi by 2, what does that mean? 3x belongs to 0 to 3 pi by 2, right?
Yes, sir.
Okay, when and 3x belongs to 0 to 3 pi by 2, then it will change signs, right?
Yes,
Understood?
sir.
Where will it change signs? When this one, at when x is pi by 6, okay, what will be 3 pi by 6? It is
Sir,
pi by
now
2.
can you hear the sound or is it proper, sir?
No, it is fine.
Yeah, yes, sir.
Understood, ma? What we are trying to say?
Yes, sir.
Ritik, are you clear here?
Yes, sir.
Okay, when x is 30 degrees, okay, what we are trying to say is 3x will become 90 degrees, right?
Yes, sir.
Okay, and cos 3x will suddenly start becoming negative when x is 30, right? Because
Yes,
cos
sir.
90 beyond cos 90, right? When x is greater than 30, cos 90 whatever that part will become negative, right?
Yes, sir.
Okay,
Yes, sir.
now and from there and after that up till x equals to 90, 3x will become 270. Up till that it is always negative, right?
Yes, sir.
The slope is
Yes,
negative,
sir.
right? Between x and x 30 and 90, x 30 to 90, okay, 3x will be 90 to 270.
Yeah.
Okay, 90 to 270, that is this is always negative, right? Okay,
Yes,
Yes,
sir.
sir.
and between 0 to 30, it will be between 0 and 90, right?
Yes, sir.
0 to 30, if x is between 0 to 30, 3x will be between 0 to 90. At this point, cos 3x is actually positive. Okay, when x is between 30 to 90, 3x will be between 90 to
90
270,
to 270.
and this will be negative. What does that mean? The function is increasing when the slope is positive between 0 to 30 and decreasing when the slope is negative between 90 to 270. That is x between 30 to 90. Understood? That's what he is
Yes,
saying.
sir.
0 to pi by 6 it is increasing and pi by 6 to pi by 2 it is decreasing. Okay, because we are
Decreasing.
talking about x, not 3x. Understood, ma'am?
Yes, sir.
Cool. So I have another class right now. We'll stop here.
Oh,
Okay. And when is our
okay,
next
sir.
class, ma'am? Wednesday, no? Wednesday evening, right? As usual.
Yes,
Yes,
sir.
sir.
Wednesday onwards,
Wednesday.
normal timing, sir. Tomorrow
Wednesday
school
evening,
starts.
5:30 India time, right?
Yes, sir.
Yes, sir.
That is your 2 p.m., right?
Sir, 3 p.m.
Sorry, sorry, your 3 p.m. by 5:30, right?
Yes, sir.
Two and a half
Yeah.
hours difference. Okay, so then we'll connect on Wednesday, your 3 p.m. Okay,
Okay, sir.
Okay, sir.
okay, cool. So what you guys do, try to finish off this one also. You'll be able to do. This is very easy. Okay,
Okay, sir.
okay.
Okay,
So
sir.
when you just need to differentiate and check when is it positive, when is it negative. That's it. Okay. All
Sure, sir.
these,
Okay,
I
sir.
think 15, 20 questions are there. Okay, when is it positive, when is it negative? That's it. Please differentiate all of this and check. You have the answers. Okay.
Okay, sir.
Okay, ma. Cool then. Take care, guys. Bye bye.
Okay.
Thank you, sir. Bye, sir.
Bye, sir. Bye, sir.